Welcome to another video. In this video, I want to find the possible isomers, the three possible isomers, of pentane. So before I solve the question is under isomerism. I will define isomerism. What is isomerism? Isomerism is the existence of two or more compounds with the same molecular formula but different structural formula or different molecular structure. Now, what is our aim? What is our objective in restructuring a particular compound into another structure? All we need to do is just to reduce the straightness of the chain. We normally have straight chain and we have branch chain in organic compound. We also have branch chain. So what we are going to do is to reduce the straight chain, the length of the straight chain, and branch the chain. That is just our objective. Now, first and foremost, let's write the molecular formula of pentane. Pentane is C5H12. So the next is to draw the original structure of pentane. The original structure of pentane is 5 carbon atoms. 1, 2, 3, 4, 5. So I'm going to label it in this way. Then each of those carbon atoms will carry hydrogen. So this is hydrogen, 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 hydrogen, then hydrogen, hydrogen, hydrogen. Let's count. 1, 2, 3, 4, 5. 5 carbon. Let's check whether the number of hydrogen is complete. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, complete. Now, the next is to write the structural formula of this original pentane. The structural formula of this original pentane is CH3, then 1, 2, 3. They are having how many CH2? CH2 into 3 places. Then the last carbon is carrying how many hydrogen? 3 hydrogen atoms. So this is the structural formula. So this is N-pentane. Then the next is to find isopentane. That is the two other isomers added to the original pentane, making 3 isomers. So what we are going to do here is to reduce the straightness of this chain. We are having 5 carbon on the straight chain. I can reduce the 5 carbon to 4 carbon. So I will lift one of those carbon on the straight chain and I will turn it to branch. I can pick one of these carbon, I can pick the third carbon here and branch it. So I will now write, I will restructure that compound. I will have carbon, 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 carbon. Then one of the 5 carbons have removed it from the original structure. I will now branch it. I can branch it to the second. If I branch it to the second, then I will put hydrogen here, hydrogen here, hydrogen here. Then hydrogen, 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 then hydrogen, then hydrogen, 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 hydrogen. Now let's check whether the number of carbon and hydrogen, whether they are complete. 1, 2, 3, 4, 5. 1, 2, 3, hydrogen, 4, 5, 6, 7, 8, 9, 10, 11, 12. Still 5 carbon and how many hydrogen? 12 hydrogen atoms. So now the new structure now, I can rename it. This one is N-pentane. I can want to name now. I will start my counting from the carbon atom that will give me the longest possible chain. If I start from here, 1, 2, 3, it's very fast. But if I start from here, I will have one long chain. So I say 1, 2, 3, 4. So carbon 2 is carrying methyl. So the name of this compound now, 1, 2, that is what? 2 methyl. 1, 2, 3, 4. When I have 4 carbon atoms, that is what? That is butane. So the name of the compound is 2 methyl 2-methyl-butane. So the original pentane is there. Then one of the isomers now I got 2-methyl-butane because carbon 2 is carrying methyl here. So I will have 2-methyl-butane. So that is one of the isomers. Then another isomer is that I'm going to reduce the 4 carbon again. I will reduce it to 3 carbon and I will rebranch it again. So how do I go about that? So I will now say that C, then I've removed another carbon to make it a branch chain. I've reduced the 4 straight carbon to 3. So I can branch it at the bottom, I can also branch it at the top. If I branch it at the top, I have carbon, then that carbon will definitely carry 3 hydrogen each. This is 1, this is 2, this is 3. This is 1, this is 2, this is 3. Now let's fix all other hydrogen. Hydrogen, one at the top again, hydrogen. Let's check for the completeness. Now let's check. 1, 2, 3, 4, 5. 5 carbon. So C5 still exists. Now let's count the hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We still have hydrogen. 12 complete hydrogen. What we only did was that we only restructured the existence of the original. So the first we reduce the 5 carbon to what? To 4 on the straight chain. And we branch it in 2 places. Then the next isomer we reduce the 4 to 3 and we branch it again. So that is just our objective. Now let's rename now. Now our naming now, I can start from, because this is odd number of carbon on the straight chain. If I start from here, I'm correct. 1, 2, 3. 1, 2, 3. I will still have the same format. So I can say carbon 1, carbon 2, carbon 3. Carbon 2 is carrying methyl both at the top and at the what? At the bottom. So that means I can now call the compound 2,2-dimethyl. Why am I calling it 2,2-dimethyl? Because carbon 2 is carrying methyl at the top. It's also carrying it at the what? At the bottom. That is why I'm having it as 2,2. Di in science means 2. So methyl at the top, methyl at the bottom. That means 2-methyl. 2,2-dimethyl. Now let's check for the parent name. 1, 2, 3. Propane. So the name of the compound is 2,2-dimethyl propane. So the 3 possible isomers are the N-pentane, which is the original. Then the next isomer is 2-methyl-butane, while the last isomer is 2,2-dimethyl-butane. So don't forget to subscribe to my YouTube channel and my Facebook, then my TikTok channel, Trigo Calculus. So have a wonderful day. Life is continuous, life is differentiable, life is integrable, but not the best measurable. It is a diet.